Today, we are going to resume subsets and Brittany's lost examination points. This is part 2. In the last video, Brittany from New Jersey asked, I took a test that asked for the definition of the term subset. I wrote part of a set and got no credit. I didn't understand my professor's explanation. Who is right, her or me? Help me, Professor N. In that video, we learned that as a consequence of the correct definition of the term subset, every set is a subset of itself. This is a violation of Brittany's definition that a subset is part of a set. In this video, we will see that the empty set is a subset of every set. Yet another violation of Brittany's so-called definition, that a subset is part of a set. Let us begin with a review of the correct definition of the term subset. Definition. Let A and B be sets. A is a subset of B means every element in set A is an element in set B. Consider the following proposition. The empty set is a subset of the set containing the elements 1 and 3. Is this proposition true or false? Now pause the video for a moment and see if you can use the definition to answer this true-false question. But please, use the definition. Don't use what you think a subset should be, like what Brittany did, but use the actual formal mathematical definition. And pause the video now. Now, before thinking about the truth value of this proposition, please recall that a proposition can either be true or false, not both and not neither. So if we are able to prove that the proposition above is false, then we must be able to demonstrate the existence of a counterexample. That is, we must be able to find an element in the empty set that is not in the set containing the elements 1 and 3. Pause the video for a moment and see if you can provide such a counterexample. Can we find such a counterexample? Pause the video and think about this. Hopefully it should be clear upon reflection that it is impossible to demonstrate the existence of a counterexample since the empty set has no elements that could possibly serve as such. Therefore, it is impossible to prove that the above proposition is false. And since a proposition is either true or false, but not both or neither, the above proposition must be true. Pause the video and reflect upon this chain of logical reasoning. So now we can state this result as a theorem. Theorem 2. The empty set is a subset of every set. If you like this video, please subscribe and give us a thumbs up.